Yeah. Next topic is system calls. Okay. Here, the system calls will provide an interface to the operating system services. System calls will provide the interface to operating system services. Like in computing, the system call is the programmatic way in which the computer program requests a service from the kernel. It's a system call is a programmatic way the computer program requests a service from the kernel is called a system call. Okay. Here the system call requests the service from the kernel of operating system and it will executes, right? That is called system call. Okay. And the system call is a way for the program to interact with the operating system. It's a, we can say it is a way the program will interact with the operating system. We call it as a system call. Okay. And a computer program makes a system call when it makes a request to the operating system kernel. Okay. When the computer program will makes a system call, when the computer program makes a request to the operating system kernel, that time it will call a system call. Okay. It will invoke the system call, we can say. Okay. System call provides the services of operating system to the user programs by using application program interface, that is called API. Okay. System calls provides the services of a operating system to user programs using APIs, application program interfaces. Here, the application developers often do not have the direct access to the system calls. Okay. Like users will not have direct access to the system calls, but they can access them through the application programming interface, that is APIs. By using the APIs, user can access the system calls. Okay. The functions that are included in the APIs invoke the actual system calls. Okay. Using API will invoke the system call. If the user sends a request for some system call to get executed, the user will send request to application program interface. Application program interface will provide the service to the users by invoking that requested system call. Okay. The three most common APIs are Windows 32 API, that is for Windows operating system. Next, 46 API for 46 based systems, like including virtually all the way versions of Unix, Linux, and Mac OS will be having 46 APIs. Next one is Java API. Java API is for the Java virtual machine. Okay, we'll be having three different APIs. Win32 API, 46 API, other one is Java API. Okay, why use of APIs rather than the system calls? Because it is a portable and ease of use purpose. We will be using the APIs. APIs having certain benefits, that is portability and ease of use. Portability means as long a system supports the API, any program using API can compile, okay, and run. Okay. And use of use means using APIs can be significantly easier than using the actual system calls. Than using the actual system calls, that using APIs we can run that system methods easily. Okay. That is why APIs will be useful than the system calls directly. Okay. Understood, right? System call is a programmatic way in which the computer program requests a service from the kernel of operating system it is executed on. Okay. It is a programmatic way of requesting a service from the kernel, kernel of operating system for execution is called system call. Okay, we will see here um, system call example. System call sequence to copy the contents of one file to another file. Here we'll be having two files, that is source file and destination file. In this example, we are copying by using system call sequence to copy the contents of source file to the destination file. Okay. Here we can see here, to do this, first input that the program will need the names of the both the files. Okay, to copy the contents of source file to destination file, first we need to know the names of both the input file and output file. Okay, that is acquire input file name, write prompt to the screen, and accept input. Accept input will accept the input file name. Okay, next acquire output file name, write prompt to the screen, accept input. Here accept input is accepting the output file name. Okay, after after knowing the input file name and output file name, open the input file name. Okay, open the input file. Okay, if file does not exist, abort. If there is no source file, what we should do? That is an error, right? We'll abort that operation. Next, create output file. That output file should be created. That new file where we need to copy the content of the input file. Okay. If this input file does not, if input file exists, then we go for creating output file. Okay. If already the file is exist, abort. Okay, else loop will start. Read from the input file, write to the output file. Okay, when this loop starts, if input file is exist and if there is no output file with the same name, okay, that time output file will get created. Read from the input file, write to the output file. Okay, until read get fails, this loop will get executed. Okay, after once that read gets fails, close the output file, write completion message on the screen, terminate normally. Okay, this is normal termination. Okay, this is the system call sequence to copy the contents of one file to another file. Understood, right? Like this, the system call will execute in this sequence. Okay. First, it requires both the file names, input file name and output file name, where we need to store the input source file contents to the destination file. Okay, for that first we acquire the input file name first and write prompt to the screen, accept the input file name. Next, acquire the output file name, we write prompt to the screen, accept the input. Here the accept the input is nothing but name of the output file. Okay, open the input file. If the file does not exist, you can't copy, right? If the input file itself is not exist, from where we'll be copying it? So that is an error, exception. So that time we'll abort it. It is abnormal termination of the program. Okay, if the input file exists, then create a output file. If already output file is exist with the same name, abort it. You can't copy the same contents to the file, right? So we'll abort it. If it is no output file with the same name, we create a new output file name. Then the loop starts. Read from the input file, write to the output file, until this read write should be done until read fails. Once read fails, close the output file, write completion message to the screen, terminate normally. Okay, this is the sequence of system calls to copy the contents of one file to another file. Understood, right? Next, this is the example of standard API. Okay, you can see here, you can here we have considered the read file is a function. Okay, here it is in Win32 API function. Okay, a function for reading reading from a file. Okay, read file is the method we are calling to. It's a function for reading from a file. Okay, it will be like this. Like bool, it is the data type of written type. Data type is boolean, and read file, and these are the parameters for this read file function. Okay, read file function, these are the parameters. And here we have described that description of parameters passed to the read file, that is handle. Okay, handle file, that is the file to be read. Okay, which file we wanted to read, that name will be given as a parameter here, read file parameter. Next is lp void buffer. It is a buffer where the data will be read into and write from. Next is dword bytes to read, that is the number of bytes to be read into the buffer. Okay, will be given by using this parameter. Next, lpd word bytes read. Here, the number of bytes read during the last read will be given as a parameter here. Next is lp over l apt OVL. It indicates the overlapped IO is being used. Okay, these are the parameters we pass to read a file. Okay, this is example. Okay, it doesn't need to concentrate much here. How it will be, we have shown here. That's it. Next, system call implementation. Here, a number associated with each system call. Every system call will be having a number. System call number will be there. A system call interface maintains a table indexed according to these numbers. By using these numbers, the system call interface will maintain a table. Okay, it maintains the table and what type of the system call, where it is procedure of that system call, where it is stored will be maintained in a table by system call interface here. Okay, and a system call interface invokes the intended system call on operating system kernel and returns the status of the system call and any return value. After executing that system call, if the system call returns some value, that will be returned to the user who requests who has sent the system call execution request. For them, it will be sent by the system call interface. Okay, system call we have discussed, right? Before the user program and the operating system kernel, the system there will be a system call interface. So that is by using APIs, the users will run the system calls. Okay, system call will be executed by the APIs here. Okay, the system call interface invokes the intended system call on the operating system kernel and it returns the status of the system call. That is, after executing the system call, what is the status? That will be returned to the user program. And any return value, if it is there, that will be returned here. Okay, the caller need to know nothing about how the system call is implemented. Okay, here the column need not to know how system call is implemented. He just knows the user of the program knows only the name of the system call. Okay, that time the implementation of that system call will be stored in the kernel. Okay, that will be executed by using the APIs here. Okay, just needs to obey the API and understand what operating system will do as a result call. Okay, that is enough. User does not need to know the how the system call is implemented in the operating system. And most details of operating system interface hidden from the programmer by APIs. Okay, APIs will be in between the user and operating system. Okay, so the APIs will hides the most of the system call implementations from the users here. Okay, managed by runtime support libraries. By using that, it will be hidden and it will be managed here. We'll see with the example here. This is API system call, okay, uh, and API system call and OS relationship. Okay, we have studied, right? Operating system will work on two different mode. One is user mode and other one is kernel mode. User mode, user code will get executed. Kernel mode, system code will get executed. In between the user mode and system mode, we'll be having the system call interface. This is nothing but APIs. Okay, here the user application, user program is requesting for the open system call. Okay, so user if know the name of the system call is enough. Here the system call interface will maintain the for every system call with system call interface will identify by using the system call number. Okay, it will be given some system call number, and where that system call implementation is stored in the operating system, the system call interface will be knowing it. Depends on whatever the system call request has come from the user, it will the system call interface will go there and it will execute that system call method, and it will send the return, it will send the uh, status of the system call, or if there is any return values, that return values will be sent back to the user application. You can see here, here will be stored, all the system call procedures will be stored inside the system kernel. Okay, it will system call interface will go and access these system call methods, and it will execute that system call and then return the outcome of that implementation, system call implementation, that will be returned to the user. Okay, understood, right? This is the mode of system calls operation. Okay, user program, if there is any system call, the control will be given to the system call interface. System call interface will run that implementation, system call implementation, and it will return the result of that system call. It can be the return some value, means it will return the value to the user program. Okay, this is API system call operating system relationship. Next, we have another example here where the C program, C program invoking a printf library call, okay, which calls write system call. Okay, here in a C program, if you have a printf method, okay, here in this C program, we don't write the procedure implementation for printf method, right? Whenever the program control identifies this printf method, the control will be given to the standard library. Here the standard library is the interface for the system call. Okay, standard library will store that what is the number for that system call, and where the procedure is stored in the operating system will be known by this standard library. It will, the control will go to the standard library, standard library will execute that write method system call, and it will return the status of that system call, and that will be returned to the user program. Okay, like this the stand system call will get executed directly. The user will not execute the system call. The system calls procedures will be hidden from the users. Okay, only through APIs the system calls can be executed. Okay, user will not know the any implementation of the system call. Okay, only the APIs will implement the APIs will execute the system calls, which are stored in the procedures will be stored in the operating system kernel. Okay, that will be executed by the APIs, and the result of that will be sent to the user programs. Understood, right? Yeah, next one is system called parameter passing. Here we have like three general methods used to pass the parameters here for the system calls. First one is simplest method. Here in this simplest method, pass the parameters in registers. Okay. In some cases, maybe more parameters than registers will be there. In simplest method, if you have few parameters, pass the parameters to the registers. We have more parameters in the register, parameters stored in a block or a table in a memory, and then and address of that blocks will be passed as a parameters in the registers. Okay, this is another method. Okay, first method, we pass directly parameters to the registers if the parameters are less. If parameters are more, then place these parameters in a block or a table in a memory and send that address through the address as a parameters in a registers. Okay, this approach is taken by Linux and Solaris operating system will be using this approach. Okay, next one is the parameters placed are pushed onto the stack by the program and popped off that stack by the operating system. This is another method of passing parameters. Okay, here the block and stack methods do not limit the number or length of the parameters being passed. Okay, but in this simplest, the number of parameters will be passed will be less. Okay, if it is less, directly we'll pass the parameters to the registers. If the parameters are more, we store the parameters in a table in the memory. That address of that location of the table will be sent as a parameters to the registers. Okay, this is the three different ways of passing parameters. You can see the parameters passing via table here. Here the parameters for the system call we have stored in the table called X. Okay, and then that will be loaded to the register as a address of the X, where these parameters are stored in a table. Table name is X. That X address will be loaded into the register. Okay, that will be passed. And what system call? System call will be identified with the system call ID. That what is the system call? That will be identified with the ID. That is 13. Here it will go to the operating system, the user parameters from the table, and these parameters will be retrieved from the table and it will be executing the system call number 13 by the operating system. Like this, parameters will be passed for the system call. If the parameters are very few, directly the parameters will be passed to the registers. If the parameters are more, the parameters will be stored in a table, and that where the table is stored in the memory, that address will be passed to the register as a parameter here. Next one is types of system calls. System calls are different types, that is process control, file management, device management, information maintenance, communication, and protection. Here, uh, if it is the process control will be having end, abort, load, execute, create process, and terminate process. Okay, these are the system calls for the process control. For the file management, will be having the system calls like create file, delete file, open file, close file, read file, write file. Okay, these are the different system calls. Next, device management system calls will be like request for the device, release the device, read, write, reposition. These are the system calls for the device management. Next, for information maintenance, the system calls will be get time or date, set time or date, okay, get system data, set system data. These are the information maintenance system calls. Next, come to the communications. The system calls will be like this, like create, delete communications, send and receive messages, transfer status information. Okay, these are the communications system calls. Okay, and here we have the example system calls for the Windows and Unix system. Windows process control system calls are create process, exit process, wait for the single object. Here in the Unix, it will same will be written like this. Fork is for create process, exit method is for exit process. Wait is for wait for the single object. Okay, it will be different method. System call will be different. Names are different, but the operations are same. In Windows, it will be like this. In Unix, it will be like this. Okay, you can see here in a MS-DOS execution, in MS-DOS, here the MS-DOS is example for the single tasking system, okay, which has command interpreter system that is invoked when the computer is started. When the computer is started, that command interpreter will get invoked. To run the program in MS-DOS uses the simple method. We use the simple method to run the program here in this. It does not create a new process when one process is running. When one single process is running, it won't create a new process in MS-DOS execution. Okay, only one process, single process will be executed here. That's what we can see here. This is at the system startup, it will be looks like this: free memory, command interpreter, and kernel. When the program is running, the program will be stored in the memory and that process will be executing here. Single process it will execute. Whereas FreeBSD runs running the multiple programs. Whereas here in this type of operating system, multiple programs will be executed. Okay, here we'll be having the process D is running here and some free memory is there. Process C also is running at the same time. Interpreter will be there. Process B also is running in the system. It is having the operating system. This is multiple programs running in this operating system. This MOS DS is single process operating system example. Only one process can be executed at a time. Okay, let's say, but here in this multiple process can be executed. Okay, next we have the system programs. uh, Okay.